Okay, so students, today we are going to start our next topic, that is impulse, and we will go through it. First, think about this situation. Suppose a fast cricket ball is coming towards you. If you catch it with hard hands, it hurts a lot. If you ever played cricket or any other ball game, any ball that is hard, and if you catch it with hard hands, it will hurt. But if you pull your hand slightly back, it hurts less. Why this happens? This happens because of impulse. Impulse means, you can see here on the screen, impulse means the effect of force applied for a short time. When you catch that ball with hard hands, what happens is time is less, so the effect of that force will be more. Sorry, with hard hands, what happens is impulse is more. That's why your hand hurts a lot. And when you slightly put your hands backward, what it will do, it will decrease the effect of force, so that impulse will decrease. This is what impulse is. Impulse means the effect of force applied for a short time. Impulse is equals to force into time. I am changing color so you can understand it better. Yeah. From here you can see the mathematical formula. Impulse is equals to force into time, effect of force applied for short time. If you can see about unit is Newton second, force unit is Newton, and time unit is second. So impulse unit is Newton second. And yeah, here we are talking about small time. That's why we write here delta t, small time. F into that small time is impulse. According to Newton's second law, if you remember Newton's second law, it is change in momentum. So according to second law, impulse is change in momentum. Impulse is change in momentum. That is final momentum minus initial momentum. The formula of momentum, as we know, is mass into velocity. So this is final velocity, and mass into u, and u is initial velocity. So this whole thing is final in momentum, and this is initial momentum. So if now from formula we can see that if we increase our force, impulse will increase. From formula you can see if we increase this will increase. Since impulse is directly proportional to force, that's why if we increase force, impulse will increase. Okay, now there is two case. When we increase force and decrease time, there is some impulse, and if when we decrease force and increase time, this both cases will have same effect. That means these two cases will have same impulse, kind of similar impulse. Like if we increases the force and decreases the time, the effect of that force is equivalent to when we decrease the force and increase the time. uh, that is why, let's say, we can take example of airbags are used in the car, cushions are used in jumping. These things do, these things just decrease the effect of that force, so that impulse will decrease. Catchers pull their hands back while catching in the ball, that I have told you earlier. So yeah, impulse tells us how much momentum changes. When we talk about like catchers pull their back, In this, what happens? Velocity slightly decreased, and that's why impulse decreased. Now our next topic is conservation of momentum. In conservation of momentum, um, first I want you to remember one thing: momentum formula, that is mass into velocity. Now suppose two bodies are interacting with each other and no external force is acting, like there is no external force. If this there is this ball and there is this ball, if they are interacting with each other and there is no external force like outside force, there is nothing, like take these as a system, this as a system, and no external force is acting on it. This is the concept. And so these bodies are interacting with each other and no external force is acting. Then something very interesting happens: the total momentum before interaction is equal to the total momentum after interaction. What I have written here: total momentum before interaction is equal to the total momentum after interaction. This is called as conservation of momentum. Conservation of momentum means that total momentum before interaction, like I will explain you further how this happens. First of all, for now just remember this definition and I will be explaining this uh, after this. Okay, so I have written in here like total momentum before is equals to total momentum after. This law works only when there is no external force. Very important thing: no external force. If there is any external force, then we cannot say that momentum is conserved. Momentum conservation law applies only when there is no external force. So this is very important. Momentum is never destroyed, it is only transferred. In this case, what happens? It never destroyed, it only transfer from one to another in the system only. Okay, here is the example. So what I am telling you is, let's say this is the ball with speed 4 meter per second and this is the ball with a speed 2 meter per second. There is no external force. This is on the frictionless surface and it is just moving. So this is before interaction. What happens? The speed of this ball B is less than the speed of ball A. So after some time, what happens is ball A hit ball B, and then there is change in speed of ball A and speed of ball B. There is something in the happened. The interaction happened, as it is collision happened, and this condition is after interaction and this is before interaction. So what we are trying to say is momentum at this point before interaction, momentum of this whole system is equal to momentum of this. So for explaining this, I will take you below and explain it in further. Um, just a minute. Okay, this is the case. This is before interaction and this is after interaction. So before interaction, there is this A ball of 1 kg with 4 meter per second velocity. There is this B ball with 2 kg mass and 2 meter per second of velocity. And what happened after collision is we have to find out the speed of ball A, and we have given that ball B velocity after collision is 3 meter per second. So what we will apply? We will apply our concept of conservation of momentum. So we will find out momentum before collision, then we will find out momentum after collision, and we equate both of them, and then we can get the velocity of A. So momentum before collision. What happens here? Momentum before collision. So here there is two body A and B. So momentum of A plus momentum of B. Momentum of A. What is momentum? Mass into velocity. So mass of A is 1 kg. So 1 kg. Velocity of A is 4 meter per second square. 4 meter per second square. Plus momentum of B. Momentum of B is mass into velocity. So mass of B is 2 kg. Here is 2 kg. And velocity of B is 2 meter per second. So here 2 meter per second. Then we solved it. 4 into 1 is 4, 2 into 2 is 4. Unit will be kg meter per second. Then we get 4 plus 4, 8 kg meter per second. This is our momentum before collision. Now we will find out momentum after collision. So in this momentum of A, so we don't know, let's remove this for now. So we don't know the velocity of A, so we are assuming it as V, and we know the mass of A, we know the mass of B and velocity of B. So we will write momentum of A, momentum of V. Momentum of A is mass of A into velocity of A. So mass of A is 1 kg and we have assumed velocity as V. Now momentum of B. So mass of B into velocity of B. Mass of B is 2 kg and velocity of B is 3 meter per second. Now we will solve this. So 1 into V is V, 2 into 3 is 6. So this comes to V plus 6 kg meter per second. Now we will apply conservation of momentum. That is, momentum before collision will be equal to momentum after collision. So we can see from here, before is 8 kg meter per second, we have right here, and after is V plus 6, V plus 6. So we will solve it. 8 is equals to V plus 6. We will take 6 to the left, so it will turn to 8 minus 6. Then we will find out V is equals to 2, that is 2 meter per second. So this will be the speed of ball A after collision. So how do we solve this? We solved it by using our concept of conservation of energy. So this is how things work for conservation of energy concept. Now we'll get back and we will move forward to our next topic. Okay, so first take some example for conservation of energy. Like when a bullet is fired forward, the gun moves backward. If you have tried a gun anytime, like in a mela or something, if you ever tried to fire a gun, fire bullet from gun, you have experienced that when we fire the bullet, what we have experienced, the gun is moving backward. This happens because of conservation of momentum. So in this case, bullet gets momentum forward and gun gets equal momentum backward, so that the whole momentum gets conserved to 0, because earlier gun and bullet both are at rest, so momentum is 0. And similarly, if there is conservation of momentum, we should have whole momentum 0. So if something is moving forward from the system, something must be moving backward, so that overall conservation will be equal. Yeah. Second example you can take is a rocket throws gases downward. So in this case, what happens? Rocket throws gases downward, and to conserve momentum, rocket will in turn moves upward. So in this case also, momentum of gas plus momentum of rocket will be constant. And the third example can be that I have told earlier, that collision of ball. That if two balls collide, if there is a change in speed, it must be like someone gets speed, then there is if there is increase in one ball's speed, there must be decrease in another ball's speed. So that's how conservation of momentum occur. Momentum is never destroyed, it is only transferred. What I have told you earlier, that momentum is never destroyed. Remember this, and remember this also, no external force should be present to apply this conservation of momentum. Now we will go forward with the next topic, that is friction. Tell me one thing, why does a moving ball stop after some time? Have you ever think about it, that when we roll a ball, it will stop after some time? Why it will happen? It should move on and on and on. Why it stops after some time. Why don't object move forever? Because of the friction. It happens because of the friction. If there is friction, then if I roll a ball or I move any object, it will get stopped because friction try to oppose the motion. So the very basic formula of definition or concept of friction is a force that opposes motion or that opposes relative motion. So what happens is, when we let's say, um, when we try to move object, or when we move object, it will stop after some time because there must be some force acting opposite to it. That's why there is change in their velocity and it becomes zero at the end because of the friction. So it acts between two surfaces. Okay, for friction there should be contact. Without contact there is no friction. Friction always apply if there is contact, and it is in the direction opposite to the motion. Now there is types of friction. There is three type of friction: static friction, kinetic friction, and rolling friction. So for static friction, let's suppose there is a 1000 kg block, this 1000 kg block, and you try to push it. For a normal person, a 1000 kg block, you can't push it. So it is at rest. We can apply Newton's second law on it, that there is a force that you are applying, let's say of 10 Newton, and friction will be applied in the opposite direction of motion. So it will be in opposite direction. If you are applying your force in the right direction, friction force will be on the left direction. So if we apply Newton's second law to this, let's see what we get. So 10 Newton applied by me plus friction is equals to 0 because this object is at rest. And what is the formula? F is equals to ma, that is total force is equals to mass into acceleration, and acceleration is 0 for this, so we have written 0. So what we get, friction is equals to minus 10 Newton. Minus is just for sign that it is in the left direction. So 10 Newton. Now here friction is 10 Newton. Let's say I take one of my friend and we both are trying to push this object. So I am applying 10 Newton of force and my friend is also applying 10 Newton of force. Then we again do the then we again apply Newton's second law. So when we apply this, 10 Newton plus 10 Newton plus friction is equals to 0. Now I am getting friction value as magnitude 20 Newton. If I bring one more friend, then there is one more 10 Newton, then friction will be minus 30 Newton. So from here you can see that friction is changing. If I am here alone, it's 10 Newton. If I am bringing my friend, it becomes 20 Newton, and then I am bringing my one more friend, it becomes 30 Newton. So we can see that friction is changing. Now I bring, let's say 5 friends, and we 5 people try to move it, and at this point this just moved. So at the point where the object it starts moving, at this point the friction is the braking friction. Okay, so from here we can say static friction changes till it reaches its maximum value. And for this case I am saying just ki 5 friends, when I am bringing 5 friends and applying 50 Newton, this objects start moving. So for this, that maximum value is 50 Newton for this case only. So here there is a main concept for static friction is that static friction changes until it reaches its maximum value. It will change. Static friction acts when the object is at rest. The basic definition is static friction acts when the object is at rest. As you can see, object is not moving in this case. And the second most important thing is static friction changes till it reaches its maximum value. Now we go ahead with kinetic friction. Kinetic friction is when the object starts moving. Static friction disappears and kinetic friction will act. When objects starts moving, then kinetic friction acts. Now, if you have tried to slide a heavy object, you definitely have felt that at the start, at the very beginning, to push it, it's hard to push. But once it starts moving, it is slightly easy. Not much difference, but it is slightly easy to push as compared to push it when it is at rest. It is slightly easy when it is when it comes to motion. It becomes easy for us. Slight difference there is. So that's where the this concept comes, that if object is moving and this friction, this moving friction that we called as kinetic friction, is less than static friction. Kinetic friction is less than static friction. There is not much difference, but yeah, there is a reasonable difference. There is a significant difference that we can see. Now third is rolling friction. So rolling friction is very small. This you can understand. Let's say if I put a uh, let's say to ride a bicycle, we put a rectangular tire and try to push it. It is hard. It will be hard to push. But when we put that when we see our usual bicycle, it has circular triangle and it is easy to roll. Even though it is not like there is no friction, there is friction, but since this is rolling friction, it's easy for us to move. That's why rolling friction is very small. uh, uh, we can say opposite, because rolling friction is very small, that's why it's easy to roll or to ride a bicycle or any vehicle. Yeah, every vehicle we use works on circular tire. So yeah, this is the concept of friction. There is three types of friction: static friction, kinetic friction, rolling friction. Now this is very important thing, that friction is necessary evil. uh, because of friction, if we see that if we see car, the tire of the car tear and it reduces its efficiency. And like if we can say that what if friction was not there, if we start moving we can get anywhere without any fuel. Don't have to use anything if friction is not there. But this is all the positive aspect of it. If there is no friction, there is no tear in the tire or any loss of energy. So this is the positive side. But negative, this is all the things, like if friction does not exist, we go very smoothly. But if friction does not exist, we cannot even walk. Because of friction we walk. Because there is friction, we push ground backward, then ground pushes us forward. That's how friction works. So friction is evil, but it is necessary evil. If friction is not there, we cannot do anything. And because of friction we have many disadvantages, we have many energy losses, but it is needed for life. So yeah, friction is a necessary evil. Now the next topic is free body diagram. So to solve any question, you should make free body diagram. By making free body diagram, you have solved half of your problem. It is very important to make free body diagram. you can see things, you can see your numerical clearly, that what is happening, what the question is asking, what question has given already. You can see all the things very clearly, what forces are acting, and then it is easy to solve the numerical. So always try to draw free body diagram in physics. So there are steps to draw free body diagram, and here I have written the step. First is draw the object separately. Like, let's say if there is one object here and one object on the top, try to draw, let's say this is A and this is B, try to draw A separately and B separately, and then show what are the forces acting on it. You can see things clearly after drawing it. Draw separately, isolate the body, just remove, draw A isolated, B isolated. Show all the forces acting on it. Show each and every forces acting on it. Whatever the question has given you, show all the forces so that you understand it very clearly. Okay, there must be something of, okay, just a minute. Okay, the free body diagram part, I think I have covered in the next, yeah, I will be covering in the next lecture. You can see free body diagram lecture in the next part. Okay, so I am stopping it here and going to our questions. So here are this question. There are a ball of mass 2 kg and its initial velocity is 2 meter per second and final velocity is 4 meter per second. Now we have to find out impulse. So what is impulse? Impulse is change in momentum. Change in momentum means final momentum minus initial momentum. So final momentum is mass into final velocity minus mass into initial velocity. Mass is same, so we have taken mass common, and this is v minus u. What is final velocity? 4 meter per second. 4 meter per second minus initial velocity. What is initial velocity? 2 meter per second. 2 meter per second. 4 minus 2 is 2. 2 into 2 is 4 kg meter per second. So this is the impulse. So this is the question, and the collision part I have explained it earlier. Now here are some MCQ questions. So impulse is equal to force into velocity? No. Impulse formula is force into time. Mass into acceleration? No. Mass into acceleration is force. Change in momentum? Yes. From Newton's second law, what is impulse? Change in momentum. Momentum into time? No. Force into time, not momentum into time. So these all are wrong, and C option is correct. Now SI unit of impulse. So what is impulse? Force into time. So what is unit of force? Newton. Unit of time, second. From here we can find out that unit of impulse is Newton second. But when we see here, there is one that is Newton, but only Newton is unit of force. So this is eliminated. Other than this, we can't see directly Newton. So what we will do? What is force? Mass into acceleration, and there is this time. Unit of mass kg, unit of acceleration meter per second square into time second. So kg meter upon second square into time. This is cancel out with 1s, and what we are left with? Kg meter per second. This is matches with B option, not C. Here is power of s is -2, so no. The joule it is not, so we get option B. We can also find out it from this, that impulse is change in momentum. Change in momentum. What is momentum? Mass into velocity. Unit of mass is kg, unit of velocity is meter per second, kg meter per second, kg meter per second. Okay, now our next question is, a force acting for a longer time produces. If a force acting longer time produces, what produces? They are talking about impulse. So what we will do, we will write formula of impulse. Impulse is equals to force into time, and it is what it is doing, force acting for longer time, that is it is increasing time. If we increase time, what will happen? Impulse will increase. So we will select that option. Less impulse, no, it will increase. No impulse, this is wrong, there will be some impulse. More impulse, yes. Zero impulse, no. Yeah, the option C is correct. So yeah, that's it for the class. You can get notes and all the things from the classroom, and yeah, try to read all the theory again and try to solve questions. Yeah.